All right, this is the review video for Algebra 2 Unit 5, also known as Pro Unit 4. We're just going to go through these questions real quick for you guys and get you set up. Looking at this first set, obviously I skipped the vocabulary at the top of the page to make sure you look over that. We're looking for the vertex of a quadratic function and the solutions or roots of a quadratic function. For both of those things, we will have a given quadratic function that we're going to need to go over to our graphing calculator. So we'll go over to Desmos and we'll type it in. I already have it typed in here just to kind of save some time, but once you type in the function, you'll see your graph, and that's the things that we are looking for are going to be our vertex here, which is this point here at 1 and -8. I don't know why it's giving me two of them. 1, -8 is the answer for the, going right here, let's bring up my writing tools, let's change the color here, yeah. So my vertex is 1, -8, and the solutions are going to be the same as the x-intercepts. So they're going to be two of those here. We're going to have one right there at -1 and another at 3. And so we'll write the names of those points for my other part of my answer. -1, 0, and 3, 0. So this is number 1, the vertex. This is number 2, the solutions or the roots. That's all you got to do for those. So that's the first one. Looking at the next problem, this says find the a, b, and c values. The a, b, and c values refer to the coefficients of the different terms in a quadratic function. This is the a term here, this is the b term here, and this is the c term here. So my a value would be 3. My b value would be -1. Again, it's negative because of the minus sign, but it's a 1 because there's an imaginary 1 in front of that x as the coefficient of that number. And then the c value would be +5. So that's pretty much all you have to know on those, because we're going to solve those using the graphing method that we did in the first part. So that is everything you need for a, b, and c. Let's look at the next little thing here. Adding complex numbers. Okay. For adding complex numbers, you're just going to add the constants, which are going to be 2 and 3, and then you're going to add the numbers that have imaginary numbers, which is the the 4i and the -2i. Notice I'm including the minus there. So when I add these up, what I'm going to be getting is I'm going to get 2 and 3 added together. That's going to make 5. And then I'm going to do 4 minus 2, which is 2. And so it's going to be 2i, because 2 plus 3 is 5, and 4 minus 2 is 2. So that would be the final answer for that. Same idea with subtraction. I'm going to add and subtract the different types of numbers with each other. So the 8 is going to be 8 minus 4. So that's going to make 4. And then it's going to be 3i minus -i. So this is going to end up making it into +i, because there's a minus here and a minus here. Those end up canceling each other out in a sense and making +i. That's a 1i, so 3i plus 1i is 4i, and that is the answer for that. So it's really just doing what you would do with any polynomials, just adding like terms. So the constants get added together and the I terms get added together. Sort of similar as we move down the page. For multiplication, it's going to be very much like the FOIL method that you learned when you were working with polynomials. When we say FOIL method, it means we're going to do multiplying this 3 times both of those terms, and we're going to multiply the 2 times both of these terms. So we're going to end up with 4 different multiplication situations here. The first is going to be 3 times 6. So 3 times 6, I'll write that down, 3 times 6. And then we're going to do 3 times -3i. That's the second one. And then going to the 2i, we're going to do 2i times 6. And then we're going to do 2i times -3i. And then what we have to do is we have to run through that whole thing, and we have to multiply and reduce anything that we can. So 3 times 6, that's 18. 3 times negative 3i is negative 9i. So I'm actually going to get rid of this plus sign because the answer here is going to be negative 9i. Then 2i times 6 is going to be 12i. And then 2i times negative 3i is going to be negative 6i squared. So let me get rid of that. That's going to be negative 6i squared. Now we need to do something with that because something we learned earlier is because I equals the square root of, because I equals the square root of negative 1, then I squared equals negative 1. So we're going to use this idea right here with this I squared, and we're going to need to deal with that right now. So looking at this, we're going to go through the problem. We're going to rewrite this. We're going to get our 18 at the beginning. The negative 9i and the 12i need to be combined, added together. That's going to make 3i because negative 9 plus 12 is 3i. And then negative 6i squared is going to become negative 6 times negative 1 because of what we talked about right here. And so that's going to make plus 6. So we're taking this and turning it into that, and then we're taking that and we're turning it into the 6. And then lastly, we're going to jump over, and I'll put my answer up here. We're going to move our answer up here. 18 and 6 need to be added together. That's 24 plus 3i, and that's the reduction of all of that after it's multiplied out. So you're doing the FOIL method. It's just that you have to remember these other little things, especially this I squared thing. That's going to come into play every time you FOIL complex numbers. Looking at the bottom section here, one thing you need to know here is that you are not allowed to have i's in the denominator of your fraction, and that is what we're going to be doing here. We're going to be working to get rid of this. So we are going to multiply this and this on the top and the bottom. Now that is called the conjugate. So a conjugate is when you take the opposite sign from the denominator, that's the denominator, and you multiply both the top and the bottom by that. So this is a pretty complicated problem, but really it's just two versions of what we did in number 6. So we are going to do this times this, and then we're going to do this times this. So both of those are going to end up being multiplied out, just like we did in this previous problem, and worked out into a solution. So again, I gave you multiples to practice, but you're going to work through all of that multiplication. Okay? So here's what it's going to look like for this one. The numerator, or the top one, is going to be, grab another color. 2 times 3 is 6. 2 times 4i is negative 8i. I times 3 is plus 3i. And I times negative 4 is negative 4i squared. I'm sorry, let me get that line a little bit better here. Now the bottom is a little bit easier. Because of some rules that we know that when we multiply numbers that are a plus and a minus with the same two terms, it's just going to be the first term squared, so that's going to be 9, which is 3 squared, and the second term squared, which is 4i, so that's going to be 16i squared. Now we have to simplify this. So we're going to work through this to simplify. We're going to go in and we're going to add everything that we can. We're going to convert all of our I squareds. So this is going to end up being 6 minus 5i, because 8i, negative 8i plus 3i is negative 5i. Negative 4i squared is going to end up being plus 4. I'm using the same logic I used up here. And then on the bottom, we have 9 plus, actually that's going to end up being negative because it's going to be negative 1. It's going to be 16 times negative 1, which is minus 16. And looking at the next part, 6 plus 4 is 10 minus 5i over negative 16, and that is the final answer for number 7. I'll leave the second part there for you to do on your own, just to get some practice in. All right, looking at our next section, we are looking at solving solutions to quadratics that have imaginary solutions. In this, you're just solving these equations like you would any algebraic equation, except something strange is going to happen near the end, and we'll kind of talk about what that is. So we're going to solve this. We're trying to solve for b. So to do that, we're going to start by subtracting 13. This is all just basic algebra. It should be very familiar to you. We end up with b squared equals negative 9. I'm going to bring this up here. So we have b squared equals negative 9. To solve for b squared, we need to take the square root of that. And this is where the problem arises. The square root of b squared is b, but the square root of negative 9, if you type that in your calculator, for instance, if I try that over here, and I do the square root of negative 9, undefined. Okay, that's because it's one of these imaginary numbers that we've been working with. So in order to solve this, we're going to split it up. We know that negative 9 is made up of the square root of 9 times the square root of negative 1. And we know that the square root of 9 is 3, and we know the square root of negative 1 is also known as I. And so actually, we're going to say our final answer is that b equals 3i. And that's the logic behind all of these. This next one is very similar. We're going to divide by 5, divide by 5. We're going to cancel that out. This is going to be k squared. K squared equals 20 divided by 5 is 4. Then we're going to take the square root of both sides in order to solve it. Square root of k, square root of 4, k equals 2. And that's the answer to that one. It's pretty basic, except for this first problem, you just got to remember to deal with your negative 1 inside your square root. Lastly, we have a pretty simple problem that is going to deal with Desmos again. They're asking us to find the solution. The solution means where do these two cross? Now what's interesting about these is that this first one is a quadratic function, which means its graph is going to look like that. And the second one is a linear function, which means its graph is going to look like that. And so we're going to be looking for the places where the graphs cross each other. So we're going to hop over to Desmos. We have y equals x squared minus 3x plus 10, I believe. Minus 10. And we have y equals 3x plus 6. And that's it. We found one of our places on the graph there, and I need to zoom out enough to see the other one. There's one right here as well. So we have two places on the graph where the lines intersect. They intersect at negative 2, 0 and 8, 30. Negative 2, 0 and 8, 30. And those would be my solutions right there. That is it for this unit. Good luck on your test. Reach out to me if you have any questions.